right, hello class, Math 1332. So I am continuing with a review for that test review. And last time I left off was on problem number 28. And so now I'm going to work on, let's see, I think it was actually 29. Yeah, I finished 28 last time, so I need to pick up with 29. Okay, so 29 is another asking of solving an equation. And on the test review that I generated, I have 5 times the quantity of x plus 3 plus 6 equals 10x minus 5 times the quantity of x minus 6, okay? And so if you've generated a test review for number 29, you'll have something similar, but different numbers, but a similar format, okay? And so what I'm noticing when I'm getting ready to solve this equation, the first thing I need to do is I need to do distributive property. Okay, so generically it kind of looks like this: A times the quantity B plus C. So you want to do a lot of multiplication here. See, A is the distributor, A times B, and then A times C. And you just have to be careful with your signs, okay? So remember that if you have the same signs, remember, same signs produce positive results, and that's when you're multiplying two numbers at a time. And different signs that produces negative results, okay? All right, okay, so I'm going to show my arrows here. Got distributive property going on to the far left, and on the far right hand side I've got distributive property going on. See, that's a negative, so be careful with that, -5. Okay, so here everything is positive, so these are going to be positive products. Product is something you get when you multiply. So 5 times x is 5x, 5 times 3 is 15, and I'm going to add that 6 here. And on this side, bring down that 10x. And then be careful here, -5 times x, that's different signs produce negative results. So that's a -5x. And then look at this, negative times negative, that's a positive. See, same signs produce positive results. So you do want to be careful with your signs. Okay, and then after we do the distributive property, I'm going to change my ink, because after we do the distributive property, then we're going to combine like terms. And sometimes students make a mistake here because sometimes they're real quick to try and do the addition principle of equality. They try to add opposites here, but really you should combine like terms first, and then you can do the addition property of equality. And so things that can combine, looks like I can combine these constants. These are constants on the left hand side. And on the right hand side, looks like I can combine these variable x terms. Okay, but you do want to combine like terms. Okay, so 15 plus 6 is going to be 21. So I have 5x plus 21 equals, and 10x take away 5x, that's just 5x. Yeah, so if you have 10 and you take away 5, you're just left with 5 plus 30x. Excuse me, plus 30. Okay, and so you notice how this is not an identity where we have all real solutions, all real numbers are solutions, infinite number of solutions. Notice how that's not happening, because this is not identical. It's not identical, okay? And so I'm going to continue solving this, and I'm going to add opposites on the x's. So I'm going to move this 5x over here and add opposites. Negative 5x, negative 5x. And look what happens. Not only does this side zero out, but so does this. And you didn't do anything wrong. This is the third thing that can happen. So remember when we did 28, we said there was three things that could happen. You could either have one solution, or you could have no solution, or you can have an infinite amount of solutions. Okay, those are like three things that could happen. So this is one of these special cases. So these x terms cancel out, and look what you're left with. 21 on this side and 30 on this side. Okay, so that's a false statement. 21 does not equal 30. That's a false statement. And so this means that our answer is that we have no solutions. Okay, so which is pretty amazing because of all the real numbers in the world, we're not able to find any number, any fraction, any decimal, any negative number, any positive number. There's just no number we can plug in here and here, everywhere you have an x, so that the left side equals the right side. So that's pretty powerful to develop that. And so there's just no solution. Okay, so if you look at your choices, you'll see that it'll say either A, the solution set is a certain number, one answer, one conditional answer, or B, all real numbers are solutions. That's when that would have been when the left side equals the right side in identity. They're exactly the same. That wasn't happening. Or for us, we have the C part, that the equation has no solution. So yeah, this equation has no solutions. Okay, so that's 29. Okay, now we're going to do 30, problem 30. So 30 is they're also asking us to solve. So we have 3, I have 3 minus 2x equals 3x plus 3. Okay. All right. So what I'll do is your goal is to put all the variables on the left side of the equation and all the constants on the right side. And so we're going to do that by using the addition principle of equality. So we basically want to, add opposites. Okay, so what I could do is I could start by moving this 3x over to this side over here, and then I can work with this constant, move this constant over here on this side. Okay, so I'm going to, opposite of 3x is a negative or a minus 3x, and these 3x's will fall out. And then notice how I have a negative 2x plus a negative 3x. Okay, so a negative plus a negative is still a negative. Okay, you owe somebody 2x's, you owe somebody 3x's, now you owe a total of 5x. So this is what I call in my elementary algebra class rule number 1. You're adding two negatives, so you just add and you keep the negative sign. Okay, so that's a negative 5x. Okay, again, can use this as a tool if you want to double check that. Now you can't put x terms in here, but you can do -2 plus -3. You can do that. That gives you -5. So it's -5 with respect to x. Okay. So then I'm going to put. So then I have here then 3 minus 5x. So this 3 minus 5x equals 3. Okay. And then now I need to move this constant over here. So the opposite of 3 is a -3. So I have -3, -3. And now these will fall out. And so I have -5x equals, and look how we have additive inverse. Remember that these are happen to be additive inverses. So additive inverses. So a number plus its opposite zeroes out. So additive inverses zero out. A number and its opposite zero out. So this equals 0. Okay. And to finish solving this, we're going to divide by the coefficient. So I'm going to divide both sides by -5. So -5 is the coefficient, not 0. 0 is a constant, just a number by itself, but the coefficient is the number in front of x. So you want to divide by the coefficient, which is -5. And then this will fall out because -5 divided by -5 is 1. That's why that kind of falls out. And then x is equal to, and remember this spells on. This is like O and then N. -5 is a number. So this spells on, like right on, right on, right on. The fonts, yes, you can do that. You can do that division problem. Also in your calculator, 0 divided by -5 is 0. Okay, so that means that x equals 0 for this particular problem. Okay, so that is 30. And they just said to solve, they didn't say to check. If they wanted you to do a check, you would go back to the original equation, and everywhere you have an x, you would plug in 0. So any number times 0 is 0. So -2 times 0 is that would be 0. This falls out. 3 times 0, that would be 0. This falls out. So you see you'd have 3 equals 3, which is true. So yeah, it checks out. Okay, they didn't ask us to check. Just meant showing that. Okay, now we're going to go to 31. So it says, let x represent the number use the given conditions to write an equation and then solve the equation and find the number. Okay, and then they say that 9 times a number is 56 more than 2 times that number, and they want you to find the number. Okay. All right, so that's what my problem generated for me. So you should have something different, probably not identical, but something similar. But that's what my problem generated for me. So this is 31. So this got chopped off. I'm not sure why. That's 31. So yeah, 9 times the number is 56 more than this. Find the number. Okay, so let's see. So if we translate that, so 9 times the number, and we're going to let x represent the number. The is like the equal sign. 56 more than, okay, so more than means to write in a reverse order. Yeah, more than is one of those special cases where you also write the terms in a reverse order. and more than means to add. So where they say 56 more than, that means that the 56 is going to go in the back because you've got to write them in a reverse order, write those terms. So the 56, instead of going in the front, goes in the back. So 56 more than, and then what goes in the front is this, 2 times that number. Okay, and remember the number we're using for is x, okay? All right, so this is the equation when you translate it. Okay, now we wanna solve this equation. Okay, so remember we're solving, our goal is to put the variables on one side of the equation and the constants, which are just the numbers by themselves, on the other side. And so I'm going to move this 2x over here. Okay, so I could put all the variables on this side and then all the constants. This is my constant on this side. So the opposite of a 2x is a minus 2x. This falls out. 9x minus 2x is 7x. And then I'm going to divide by the coefficient, which is 7. Because 56 is called a constant and 7 is called a coefficient. So I'm going to divide both sides by 7. And this will divide out. 7 goes into 7 one time. And then you can double check on your calculator, but 56 divided by 7, you see, is 8. Okay, so we have x equals 8 for that. Okey-doke. All right. Okay, so now I'm going to go to 32. So it looks like we're getting now, it looks like we're done with chapter 2, and it looks like we're getting into the graphing part, chapter 3. So it says here that it wants us to explain why this ordered pair, 6, -5, and this ordered pair, -5, 6, why is it that these ordered pairs do not represent the same ordered pairs? Okay, interesting. Okay. So, um, so if I think about, and I see how they have like a little paragraph there on our paper, and I could show you, you have your write-up up also, but you can see here, it says the ordered pair 6, -5 is located, so they have blank units from 0 to the blank along the x-axis, and then blank units blank along a line parallel to the y-axis. Okay, so we definitely need some graph paper, okay, which I happen to have here, okay. So so I have this graph paper, and also I believe I put some, if you go to your module in Canvas under the test 1 material, I believe I have several options of graph paper that you can print from there as well. Otherwise, you can just pick something like this up from any store, HEB or Office Depot. Let's see. The nice thing about the ones that I provide you is that they already have an X and a Y axis. So if you're going to use this kind of graph paper, you will have to set it up. And I happen to have a ruler here, but you will have to set it up. So this is 32. So by setting it up, I mean by making an X and a Y axis, for example. Like that. I'll have to do that, which takes time. If you do the one, my printout ones that already have that, it does save you time because they already have an X and a Y built in. And remember all the positives for X? You know, when you plot a point, and this was created by René Descartes. René Descartes. He's a French mathematician, and he's also a philosopher. And also back in the day, when he was back in the day, he was very popular. He was summoned by the Queen. The Queen at that time wanted to be tutored by him. So a queen wanted to be tutored by René Descartes. And so, but he's the one that gets credit for all this graphing ideas. And in fact, these graphs are called Cartesian coordinate planes. And so it's named after him, René Descartes. So if you're a history buff, if you like history, it's interesting to read up about him. And fortunately, he died at a fairly early age because he apparently caught a cold. So the queen liked to be tutored very early in the morning. And so they believe that he caught a cold and didn't recover from that cold very early in the morning. And back then they had castles and things like that. Didn't have central heating like we have now. And so, but he did die at a really fairly, early, um, or unfortunate situation, right? Because they say he was a sickly man. He got sick from the early tutoring sessions and didn't recover from that. But he's the one that got credit for these graphs. And so the idea is that he just woke up one morning and thought, and woke up one morning and saw an insect on the ceiling and thought, how can I identify and talk about where that fly is exactly situated, where that bug is exactly situated at. And so he came up with this grid, this idea of graphing points. So he's the one that gets credit for that, okay? That's René Descartes. He's also the thinker, the philosopher, I think, therefore I am. So that's also, we have a statue, famous statue of him created for that philosophy. I think, therefore I am. Okay, René Descartes. Okay, so to answer this question, to think about these points, explain why the point 6, -5 and -5, 6, why do they not represent the same ordered pairs? So whenever you plot a point, it's really important that you know that you always begin at the origin, which is the 0, 0. So you always begin here at the origin 0, 0. And then you study your x coordinate and see, you see your x-axis here, and this is in alphabetical order. You have to work with your x-axis first, and then after you plot that point, then you work with your y-axis. You move for that point, and then you can actually plot a point after that. But you study the x coordinate, and if the x coordinate is positive, then you want to move uh, right that many times, and then you hold your pencil. But if the x coordinate is negative, then you want to move left that many points. Okay, and then you hold your pencil. Don't be so quick to put a point just yet, because you're not done yet. All ordered pairs have some x, y coordinate. So you're only here on the x, and sometimes the x is 0. Sometimes the points can have a zero coordinate. So sometimes zero, it can be 0, 0, for example, right? So if x is positive, you move to the right. If x is negative, you move to the left. And if x happens to be 0, then you would stay. You would stay. You would not move right, you not move left, you just stay. So those are your choices. So then you hold your pencil, don't put a point just yet. So hold your pencil, don't plot a point just yet. Because, why? Because you need to account for the y coordinate. Okay, so you see this y-axis here. So then, you know, if the y coordinate is positive, then you move up that many points. But if the y coordinate is negative, then you're going to have to move down that many points. And then at that point, then you can plot your point. Okay? So that's the idea, okay? And so similar to reading a map, if you've ever read a map before, they use variables oftentimes on a grid. And so it's very similar to that, following direction on the map, okay, for location. So with 6 negative 5, with 6 negative 5, this is telling me that I start at the origin, and the 6 is telling me to move right, and then the negative 5 is telling me to go down, and then I plot my point. So I'm going to go to the right 6 times. So here I'm at 0, 0. I begin at the origin. 1, 2, 3, 4, 5, 6. You see that? 6, hold it, and I'm going to go down. Negative 1, negative 2, negative 3, negative 4, negative 5. So that's the point 6, negative 5. Okay? And so then when I see here on the blanks, it says the ordered pair 695 is located, and we want to say it's located 6 units from 0. So 6 units from 0 to the right, right? To the right along the x-axis, and then it's located 5 units down. 5 units down along a line that's see parallel to the y-axis. Yeah, and that's where we get that from. So I'm going to fill in that blank, come back over here, and I'm going to say I'm going to write that down. So the ordered pair 695 is located, and so I'm going to say it was located 6 units from 0 to the right along the x-axis and down 5 units, underlined 5 units down. So underline 6, underline right, underline 5, and underline down. So 5 units down along a line parallel to the y-axis. All right. Okay. Okay, and then it talks about the other point. So it starts off saying for the other point, however, the ordered pair and so we're talking about the negative 5, 6 is located. I'm going to just do the blanks for now. Blank units from 0 to the blank along the x-axis and blank units blank along a line parallel to the y-axis. Okay, and that's similar what your paper should have. It's just probably your test review generated a different ordered pair. But for mine, when I generated, I'm looking at the second point, which is a negative 5, 6. So when I go to the negative 5, 6, I start at 0, 0, and this tells me I'm going to have to, on my x, I'm going to have to move left. So 1, 2, 3, 4, 5. Hold my pencil, and then I'm going to go up. 1, 2, 3, 4, 5, 6. Okay. So I go left, and then I go up. So I'm right here. 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, 6. Okay, and I'm going to plot that point, negative 5, 6. Okay, so I start at the origin, and I have to go left, negative 5, and I have to go up. Okay, so in your Cartesian coordinate plane, this is positive, this is positive, so this is plus plus. Okay, and then this is over here, this is negative, whereas this is positive. So this is negative, positive. And then down here, it's negative, and then negative, negative, negative. And then over here, positive, and then negative. So this is positive for the x, and then negative. Okay, so this is x movement, y. Okay, x movement, y, x movement, y, x movement, y. So sometimes that helps students to see that positive x, negative y. Okay. Also, they're quadrants. See, this is broken up into 4 boxes, 4 quadrants. So it actually goes counterclockwise, not clockwise, counterclockwise. So this is actually called quadrant 1. This is called quadrant 2. So counterclockwise. This is called quadrant 3, and this is quadrant 4. Okay, so it goes counterclockwise. 1, 2, 3, 4. All right, so then to fill in the blank with that point negative 5, 6, see how we had to go to the left, negative 5, and then we had to go up. So let's see what they want here. However, the ordered pair negative 5, 6 is located blank units from 0 to the blank. So they say that it's 5 units 5 units from 0, and it's to the left along the x-axis, and then we went up 6 units. So then we went up 6 units up along a line that's parallel to the y-axis. Okay, so that's what they want for that. So they're checking on your movement on how to plot points. Okay, so that's 32. Okay, then on 33, oh my goodness, my printer didn't do a good job. Look at that, how light that is. I cannot see that. So I do have the original equation or the original graph up here on my computer up here. So good thing I saved that. And so let me see, I'm going to have to recreate that. Let me recreate my graph and see. All right, so the first point that I have here, I have A, and they want us to state the coordinates of the points graphed in the figure below. Okay, so let's see. And on their graph, they numbered it in groups of 2. So like they didn't put a number here, but then this would be 2. They didn't put a number here, and this would be 4. They didn't put a number here, so they put a number here, 6, and then 8. Looks like they went all the way to 10, but I don't see any points past that though. So I'm gonna over here, -2, -4, -6, -8. I also didn't see anything past that. Okay, and then they also did this and they labeled groups of 2. So this is 1, but they put 2 here, 4, 6, 8. Okay, and then down here, -2, -4, -6, -8. All right, and then I see for me, on what got generated for me, let's see, I see a point here and then up here, right there. So I see that point right there for A, okay, for on my part that got generated, my test. So to identify that point, remember when we move, we have an X and then a Y. So my choices for X is either we go right, or we go left, or we stay at 0. So for this, my point A, you can see that we went to the right, and we went to the right 5 times. Okay. And then you can see how we went up 6 times. Yeah, so for the Y, you either go up, or you go down, or you stay at 0. Okay. So for us, our point A is 5, 6. Okay. And then it's A through F. Okay, so for B, see where B is at on my graph. So B looks like it's here, and then it goes here. Yeah, so for me, it looks like it generated that point right there. That would be at my B for my problem. Okay, so we start at the origin, And we go in the negative direction. X is -6. And then we go down, down to -3. 1, 2, 3. Okay. So we go -6, and then we go down 1, 2, 3. Okay, and then my C is actually on the x-axis for my C got generated. It looks like my C got generated right here, which is right on the x-axis. So it started at the origin, and then it moved -6, and then it didn't go up or down, it stayed. So that stay is a 0. So it moved right, and then it stayed at 0. This one moved right, and then it moved down. This one moved, sorry, left, left. Okay, this one moved right, and then up. Okay, and then D, for me, it looks like it generated starting here, and then it also went down to here. So it looks like that's where my D got generated. So at 0, 0, it looks like I'm moving out to 4 this way, and then it moved down to a -5. Okay. And then my E, when it generated, looks like it generated here and then here. So that looks like it started at 0, 0, and then it went in the negative direction to -4, and then it went up to 3. And then one more F. So for F, so it's right on the y-axis. So I started at 0, 0, and then went straight up all the way right here to that 2 on the y-axis. So on my X, it didn't go right, it didn't go left, it stayed. So remember, a stay, if you don't go right, if you don't go left and you stay, that's a 0. And then it went up 2. Okay. All right, so that's 33. State the coordinates. I'm going to write that here. Yeah, and I did that too because see my picture, this when it printed, see how light that is? So good thing I had that in the background on my other computer here, just in case that happened. So sorry about that. Okay, it's 33. Okay, now we're going to look at 34. Let's see what's 34. I might be able to do 34 on this other page here because it says that it wants you to plot the ordered pair, which is this point A, which is -1, 9. So they want you to plot the ordered pair below in the coordinate plane. And then it asks in which quadrant or on which axis does the point lie? Okay, interesting. Okay, so again on the quadrants, remember we said about the quadrant. So let me do this. So it looks like I didn't use enough paper. Sorry, let me see. Because I see that 9. I'm not going to have enough to go up to 9. Let's see, let me erase this. Okay, I should be fine if I do this then. So I think I have enough room if I do this here. So this is my x-axis and this is my y-axis. And if I plot this point, -1, so -1 means that start here at the origin, right, at 0, 0, 0, 0, and I go left 1, and then I go up 9, okay? So I'm here at 0, 0, I go left 1, -1, then up 1, 2, 3, 4, 5, 6, 7, 8, 9, right there. Just A. So -1 and then up 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's my -1, 9. So it says in which quadrant or in which axis does the point lie? Yeah, so a point either lies on an axis. See, this is the x-axis, and then this is the y-axis. So this point doesn't lie on axis. If it were to lie on axis, it would have been here. Okay, like over here, right here, C lies, point C lies on the x-axis. And as far as the y-axis goes, see, this is x, this is y. So you can see here that F, you can see here that point F, that lies on the y-axis. So points either lie on an axis, the x-axis or the y-axis, okay? Or if they don't lie on an axis, they lie in a quadrant. So that's why we're talking about the quadrants. This would be, if it lies in this box, this is called quadrant 1. And we say it goes against the clock. If it lies here, this is quadrant 2. So counter means against, counterclockwise. Then this is quadrant 3, and then quadrant 4. So for us, you can see that our point -1, 9, you can see that our point lies in quadrant 2. So in which quadrant or in which axis does the point lie? So -1, 9 lies in quadrant 2. And they like to use Roman numerals. 1, 2, 3, 3, 4. They like to use Roman numerals. Okay, so that's 34. Okay, now I'm going to go to 35. Okay, so graph the linear equation in 2 variables. Find at least 5 solutions in the table of values for the equation. Okay, so our equation is that y is equal to -12, or they say that y is equal to 0x minus 12. Okay, because 0 times anything is 0, then this just disappears. And so that's why you just have -12, okay? and they want you to find 5 ordered pairs that are solutions for the equation. Okay, so and then they have a table. And then let's see. Okay, so x is -2, x is -1, x is 0, x is 1, x is 2, and then they want you to, complete the table here. Type your ordered pairs. Okay. So, um, so here, this is kind of what we have right now. X is -2, x is -1, x is 0, x is 1, x is 2, right? And then you've got to put something down for y. Well, they're telling you that, look, y is always -12 on this problem. In this problem, y is always -12. So right here, this should be -2, 12. This is -1, 12, 0, 12. And it's actually supposed to be negative. It's actually supposed to be negative. So let me put a little negative there. So excuse me. Okay, -12. Okay. So then you see you have graph paper there. You see this is my graph. It's really light. Okay. So then if I plot that on graph paper, for 35, this is 35. And since it's a -12, that's my y, x, x, and then y. And my y, you can see it's -12, so it's always going to go down. So I just want to make sure I have enough points there, coordinates. So I'm making this my x-axis. This is making this my y-axis. Okay, so when I start plotting these points, so in my table, I would have to fill in my table there, and y is always -12. But then when I start plotting these points, I see a graph paper there, so I have -2, -12. So I come to the left here, -2, and then I go all the way down, -1, -2, -3, -4, -5, -6, -7, -8, -9, -10, -11, -12. And then I just come over here because it was -2, -2, -12. Excuse me. Okay, so -2, -12. Okay. And then I have -1, -12. So -1, -2, -3, -4, -5, -6, -7, -8, -9, -10, -11, -12. So I have -1, -12. So you're starting to get a feel like it looks like it's going to be when you connect the dots, it looks like it's going to be, that's a horizontal line, okay, for y equals -12, okay? So if I continue, I have 0, so 0 is right here, 0, -12, then I have 1, -12, so then I come over here, 1, then I go all the way down to -12. Then I have this last one, 2, -12. So 2, and then I go down, -1, -2, -3, -4, -5, -6, -7, -8, -9, -10, -11, -12. See that? So I'm at 0, 1, 2, negative 12. Okay, and then I'm going to draw my line. Put arrow tips here, and then this is the line y equals negative 12 for 35. So they do want you to complete the table, which we did, and then they want you to use this graphing tool to graph the equation. So remember, I did include a couple of videos, some helpful videos for the graphing to help you graph that in your Canvas course. In the area, the module talks about MyLabs Plus. So I did put some videos in there that help with the graphing too for that. On that, let's see. What I also don't like about the system that they don't put the arrows, that kind of bugs me when you draw a line, because it always looks like a line segment. When you draw a line, you've got the arrows on the end. So I kind of don't like how my math lab just draws like a line segment, no arrow tips on the ends there, so it looks like a segment instead. So, but no system is perfect. So, okay, let's look at 36. Okay, and 36 I'll do on the same paper. Excuse me. 36 says that they want you to describe the graph of y equals 200. Describe the graph of y equals 200. Yeah, so based on the one we just did, 35, I would say when I think about the graph of y equals 200, I would say looking at number 35 where this is uh y equals negative 12, I would just have um you know, y equals 200. So this is my x and y axis, and y is 200 way up here, way at the top, 200. But you would have a horizontal line way at the top. So when they say describe the graph, we want to say that it's a horizontal. It's definitely a horizontal line that is drawn through the point where you're at 0, then you go up all the way to 200. So if you can go from, imagine going 0, 0 all the way up to 200, and through that point you would draw a horizontal line through that point. That's kind of what happened here. See, y equals negative 12. So this is the point 0, negative 12. So through that point 0, negative 12, you just drew a straight line. Okay. So that answers 36. Describe the graph of y equals 200. It's a horizontal line. Okay, excuse me. Okay, and then I'm looking at 37. So I'm going to draw another little generic graph. And it says they want you to write an equation for the graph. So I have a graph that looks like it's going horizontally through 3. Okay, so let's see. Excuse me. So 1, 2, 3. So I see my picture when it generated a problem. I see this. That's what I see. Okay, so they have the arrow tips here, and they want you to write an equation for this graph. Okay, and so what will help is if I just pick some points through do we need 2 points, you can draw a line, but if you can pick 3 points on the line, that just guarantees that your work is correct. So if I just do this, you know, pick points on number 37, which is, it tells you to write an equation for this graph. So if I just randomly pick some points, I'm going to say randomly choose at least 3 points on the graph. So if I just pick on these, see, I just randomly picked on those to see what they would look like. This one is at the origin 0, 0. So this one would be x is 0. I don't go right, I don't go left, and then I would go up to y 1, 2, 3. So everybody's y should be a 3 then. But look at this point here. This point would be 1. X is 1. And then I don't go up, I don't go down, it's 0. Oh, excuse me. So let's see. Actually, I take that back. So x is 1 and y, excuse me, x is 1 and y is 1, 2, 3. Yeah. So this is 0, 3. This is 1, 3. Okay, so then I need to label this one. Again, the x, y, the y part, that would be 3. So, because I'm right here at 0, so I go 1, 2, 3, right? And then my x is here. Here's my x. So -1, -2. Yeah, so it looks like I have -1, -2, and then 1, 2, 3. So -2, 3. And it looks like those are my points. Did I? Yeah, I got all of them. So this one goes here. That goes there. Okay. So when I'm writing an equation for this graph, I'm suggesting that you randomly choose at least 3 points on the graph, and then you study or you see uh, what's in common. Excuse me. And hopefully you'll notice like what's in common. Notice, this is the x coordinate and the y. The x coordinate and y. Do you see how the y is the same? See that? This is the x and the y. All these different situations that you have, but you see how the y is always set to be 3? And yeah, that's your pattern. They want you on 37 to write an equation for the graph. And this is a horizontal line. They started off going to the point 1, 3, okay? And so when you write an equation for the graph, so we would say that we have the equation is, excuse me, y is equal to, and look what you have in common. All the y's are 3. So y is equal to 3 on that problem there. Excuse me, I'm sorry. So let's see. So write an equation for the graph. So there's your graph. Let me highlight that so you can see it. So what I did was I randomly chose at least 3 points on the graph, and I studied what's in common. So I also labeled And then I saw something, excuse me, in common. Excuse me, once I labeled them, I saw something in common, and they all had that the y was 3. So label the study what's in common, label the points. And so I noticed that all the y coordinates are 3. So yeah, y equals 3. Okay? So that's 37. That would be your equation, and we'll know the equation. Okay, and then on 38, they want you to graph the linear equation x equals 1. Okay, I'm going to draw my axis here, my x and y axis. Let's see. All right, so they want you to graph the linear equation x equals 1, and they want you to use the graphing tool to graph the linear equation here to the side. Okay, and so x equals 3. So what I'll do to help with that is I'll do a generic table, x and then y, and look how x is always 1. Notice how x is always 1. That's going to be important there, how that got fixed to be 1. X is always 1. So here I could put several 1s. See that? X is 1. And then I can pick any values that I want. Any values that I want for y. So note x is always 1. X is always 1 because of this. And then we just pick values. We pick values for y. And I just use 0, 2, and -3. So you just want to pick values, any x values, and we pick any values for y. So then that way if I try to plot this, we pick any values for y, and then we try to practice and plot these. Okay, and so what I'm talking about when I say these, x, y, so this is 1, 0, 1, 2, and for example, 1, -3. So I'm going to plot them. So I'm at 0, 0, and x is 1, so I go to the right, and then y is 0. Okay, then I have 1, 2, so I go to the right 1, and I go up 2. And I have 1, -3, so I go to the right 1, and I go down -1, -2, -3. Okay, and then when I connect those points, so plot these points. Okay, and this is x equals 1. So that's common there. X equals 1. Okay, so that's 38. Okay, let's look at 39. Let's see, excuse me, 39. Let's see. Let me just make sure that I didn't skip anything. 31, 32, 33, 34, 35. Just come back over here. Let me double check something. Excuse me. Oh, okay, let's see. I thought I had skipped a problem, but I guess not. So after your table, $36. I was, yeah, well, we did say, I think for 36, no, we did describe it. Just choose the correct answer, describe the graph. Y equals 200, so we have it as a horizontal line. This is also a horizontal line, y equals 3, okay. And then 38, graph that line, okay. And then let's see what 39 says. 39 says that they want you to find an equation for the line shown on the graph. Let's see. Yeah, so we do 39 on here then. So 39 says that they want you to find the equation for the line excuse me, on the right. What is the equation for the line shown on the right? So they want the equation. Okay, so they've got a little picture here. Let me see if I can draw that, sketch that. Okay, here's X and here's Y. And then we've got a line. It looks like that's a vertical line going through on the x-axis going through 5. 1, 2, 3, 4, 5. Okay, there's our picture there. So what is the equation for this line that's shown on the right? Okay, so I would start by picking any 3 points on the line. Okay, so I'll pick on that one. That's the origin. That would be if I start here at 0, 0, so that'll be 5. Go to the right 5 and up and down 0. And then I'll pick on this. So this point would be, my x again would be 5, and then my y 1, 2, 3, 4. I'll just 1, 2, 3, 4 up and down. I'll do that vertically. So this was to the right, and this was taking more time to process up, and that would be 5, and then we want to go up how many? 1, 2, 3, 4. So up 4. So to the right 5, and then up 4. And then this one again, we're going to the right 5, but then look how we're going to go downwards. So you're going to go down, and I'm going to just put the point here. So I go to the right 5 and I go down 2. Okay, so go to the right and then down. This one went to the right and you went up. And find the equation for the line. So you pick any 3 points on the line, and then you label the points like we did, and then you look for a pattern. You look for a pattern, and you see your pattern x, y, x, y, x, y. You look for the pattern and you see that it is that x equals 5. So see what they have in common. This is x, this is y. X, y, x, y. And you see x is always 5. So find the equation for the line. So pick any 3 points on the line, label the points, look for the pattern, and see that all your x coordinates are 5. So therefore we label it x equals 5, okay? Whereas over here when we're doing this problem, we randomly chose also at least 3 points on the graph. We studied to see what's in common, and then we labeled the points. So here we saw that all the y coordinates are 3. Okay, so it's similar to that. All the x coordinates were 5. So therefore x equals 5. Okay, for 39. Okay. Okay. I need to put this with 35. I'm going to put here see graph on next page. Okie doke. All right. And then let's see, as we're approaching 40, okay, I'm going to go ahead and take a break now. I'm going to take a break, and then when we come back, I will pick up with 40, okay? I'm going to stop the share. Whoops, and then end this. And in the